if I was you, I always think like I'm a grower. So, um, the disease CLR, it's the big red spot in the middle of this triangle. This triangle, you've probably seen it, but it's what everybody uses to describe what makes a disease either, I'll say, so vicious or not bad at all. And the first is the host, and you have coffee, and um, even if it's a resistant variety, it is a susceptible host, and that's what the disease is looking for. CLR is very specific to coffee. Sometimes other diseases or pathogens, as we call them, aren't so specific. They attack everything. Fusarium or Cercospora, like you get Cercospora on coffee, so that's probably a good example. They'll go to many different types of plants, but for CLR, it's very specific. So you have the pathogen, you have the host, and Hawaii, because it's such a great environment for growing coffee, is also a great environment for the disease to exist. I mean, you have the temperature, you have the rainfall, you have the wind, you have the constant humidity. So the disease is very happy to live in Hawaii, just like most of us would be. Next slide, Andrea, please. So we talk about chemistries, and I bring this up not to say what a horrible, confusing picture, but we know there's a lot of chemicals, quote unquote, on the market. Really, about 180 million different ones. But of all those, something to remember is they all fit into really 50 groups of chemicals. So all those chemicals can be narrowed down into basically 50 families. And that's important because we've got to make these 50 families continue to be viable and useful to us. Next one. What's even worse is if you look at those 50 families, there's about 3 that are used worldwide on almost all the diseases. And we classify those into groups. And you saw it in the recording where I used the word FRAC, which is Fungicide Resistance Action Committee. What that is a group of industry and international regulators, governments that kind of classify everything so we can have these chemicals on the market longer. But the 3 main groups are FRAC 7, 11, and 3. And if you notice Priaxor, our product, it's a combination of a 7 and 3, or excuse me, a 7 and 11. But these 3 groups are used on so many different things that we really have to be concerned because we want to keep them as viable for as long as possible. We want to monitor how often we use them during a season. We want to monitor how long or what we spray in between them. And we want to make sure all the labels, say what they're related to. So these numbers in black, you can actually look at on any label and say, oh, that's where it belongs. That's the family it's in. And again, we really want to prolong these as much as possible because if you look in today's world, it's about $300 million and right around 12 years to bring a new chemical to market. And very few companies, there's only about 4 of us left, really investing in chemical development. So got to keep these tools going for as long as possible. Next one, please. So when those committees get together, they really emphasize a couple things, and these are good points. I'll just go through them quickly. One, don't rely on one type of chemistry only. So don't use Priaxor, and nothing else. It will break and then it'll become ineffective for you. You need to either tank mix or rotate different groups, different family members into your program. Don't go lower than the labeled rates because that just encourages resistance, and resistance will shorten the life or the efficacy of a product. spray early and before the disease populations have exploded, especially with CLR. It's just aggressive. I know I said that a lot in the video, but it is so aggressive. It reproduces and contaminates so fast and so quickly. We've got to spray preventatively. And then we want to use multiple strategies, including the genetic resistance. So if you have genetic resistance in your coffee variety, maybe you do, maybe you don't, that's just one step of treatment or one way to attack the disease. Also good cultural practices, good pruning, good sanitation, all very, very important. And then chemical management. Next one. Okay, so this is a picture. It's a little science geeky, but where where Priaxor attacks the fungus is in that thing you see called the mitochondria. Think of that like the engine in your car. That's the powerhouse. That is giving the fungus energy. So we attack that there. Next slide, please. And specifically in a cell where you see the arrow pointing with Priaxor, we attack that in two different spots, but they're both in the mitochondria. So there's two parts to Priaxor. It attacks in two different spots in that basically the engine of the cell. This is why rotation is important. We've got to somehow kill this fungus some other way. And that can be by attacking the cell membrane or attacking its formation of enzymes or amino acids or attacking the cell wall. And whether you're using bacillus or copper or sulfurs or oils or oxidate, that's the other way. So rotation, very, very important, and in between your Priaxor sprays. Next slide, please. Even on a tinier level within the car engine, think of it like your car has 6 cylinders, you can see the two products or the two ingredients in our product attack at two spots in the engine and side by side. And that's really why it works so long. And the one that's in black there, the Xemium, the SDHI, that's the one with the long residual. So when I say long residual in coffee, because the disease is so aggressive, it's 21 days that will really knock the disease way back, and maybe a little bit longer. You might say, wait a minute, the days to harvest is 45. Well, that's because you can still find residual of that chemical. So maintain that 45 days to harvest. But, after 21 days, I'm going to tell you, you probably ought to be retreating with a contact type material that's going to help keep the Priaxor working strongly for a lot more years than if you move that out to 40 days or 60 days, or maybe only do Priaxor twice a year and nothing else. So please keep these other products in between. Next slide, please. Preventative, if this is a leaf surface, that green little line, we want to be down there before the fungal spore lands there, and that way we can stop it from getting into the leaf and reproducing, because it does that so quickly. We just really want to knock that back preventatively. Next picture, please. So there's different methods of managing the disease, and of course, normal breeding for genetic resistance is key, and it's been going on. Selection has been going on really since the dawn of man. Genetic modification is a newer way, but in Hawaii you can't do that. So whatever genetic resistance you have, you need to do everything you can do to maintain it with a chemical program. Your other cultural methods I already kind of mentioned. So, whether it's your good sanitation, your certain regulatory measures, whether it's good pruning, whatever else you're doing to keep the crop clean, you need to continue and then use chemicals where necessary. Next, there you go. So this was in the slideshow or the presentation, but just remember, we're trying to be preventative. We want to stop that fungus from infecting your plant. Curative, it works on a biochemical level, but really because CLR happens so fast, you're not going to get that out of a chemical. You're going to get that out of your resistance strains if you're using one. And then also the eradicant portion, nothing is really going to get into your coffee plant and um, wipe out the disease. Once it's in there, and you're just trying to keep the population down. Next picture, please. So let's go back to our opening questions. Should I spray resistant varieties? Yeah, because resistance is only one type of management. And if you look at the research throughout the world, it's got a maximum of about 10 years in most areas. So, you're trying to make it last the 10 years. And these were areas where they were spraying anyway. So you need as much life out of that resistant variety as you can. So, yes, you should be spraying. Should I spray preventatively for CLR? Yeah, it infects so quick that you got to get the chemicals down before that disease establishes. What's a program look like for you individually? It's everything we mentioned: resistant varieties, good pruning, good sanitation, uh, timely application, learning everything you can from Matt and Andrea and everybody else who comes along who, is an expert in that disease or at least in growing coffee in your environment. And then will IR4, EPA, and the state work to get new chemicals registered? If so, will they be different modes of action? Hopefully, but if you look at most of the products being tested right now, they are FRAC 11 chemistry. So they're related to one half of Priaxor. And what I'll say about that is they don't have the second component to help with resistance. So I think Priaxor will have the advantage. Priaxor also works better than them on the disease specifically, but please do not get confused that if you move from whatever the next two things come along to Priaxor and then back to that, don't get confused. They're all killing the same way. So back to that engine analogy, if I'm taking out the third cylinder in your engine, everything else that's coming along right now looks like it's going to do the same thing. Hopefully we'll get some new modes of action, but it's very difficult in today's world. That's it as far as information I have. I'm open to any questions, and